So we gotta stop meeting like this, guys. No. So this video is for something that you really have to understand. This is very, very, very important. This is one of the basic languages of this class, is understanding how to go from mass to moles, or moles to molecules, or mass to molecules, or vice versa, right? These can go both ways. So it's whichever way they're asking the question. So I have my predecessor always called it the mole hill. So she said the mole's at the top of the hill, and down here you have mass, and here you have molecules or atoms, right? And you cannot go from molecules to mass. You can't do that. You have to climb the mole hill first. Mole is the middle guy. He's the middleman mole, right? So if you have to go from mass to molecules or vice versa, you have to go to your middleman mole. So how do I go from moles to mass, or mass to moles? That sounds like grams to moles to me. That is the periodic table, the molar mass, right? Molar mass, yay! So this is where we use the periodic table. That's how you do this guy. How do I climb this part? Moles to molecules, or, you know, atoms, if you will. Like, it depends if you're just talking about individual atoms. What you use here is Avogadro. So let's go ahead and do a couple examples. So this is from the book. This is number 38 from the chapter 3. It has, this one's pretty straightforward. It has, what is the mass of 1.223 moles of iron 3 sulfate? Well, right away they threw me a little wrench in the gears, didn't they? They gave me iron 3 sulfate. So I'm going to real quick help you guys. Let's make the formula for that. So if it's iron 3, that means it's Fe3+, and sulfate, we remember, is SO4 2-. So I have to combine these two. So is it just FeSO4? No, because Fe is 3+ and SO4 is 2-. So what's the smallest number a 3 and a 2 have in common? The smallest multiple, least common multiple, that would be a 6. So I'm going to need 2 Fe's to have a positive 6, and I'm going to need 3 SO4's to have a -6. So the formula is Fe2 SO4 3. Guys with me on this? So that was just a little side practice. So it says, what is the mass of 1.223 moles of this bad boy right here? So start with your given. Always start with your given, put it over 1. So 1.223 moles. And I say 1 mole weighs how much, right? Because if I'm going to go from moles to mass, I use the molar mass. 1 mole weighs how much? Oh, well, I'm going to have to actually calculate it out. 1 mole of Fe2SO4 3. Okay. How many grams is that? So I need to use my calculator to figure that out. So Fe, if I look at his, on the periodic table, he is 55.845. So it's going to be 2 times 55.845 for the Fe. How about sulfur? I actually have 3 sulfurs, right? And he weighs 32.06. And I have how many oxygens? 12, correct? So 12 times 15.999. Ooh, that's going to be a big old number, isn't it? That's going to be heavy. So whatever this is, plus that, plus that. So I'm going to go ahead and calculate that out. Uh, 3 times 32.06. And I'm going to add that to 12 times 15.999. Alright, I got a molar mass. Ooh, we're running into the next problem, aren't we? 399.858. Ooh, that's big. That's heavy, right? Okay, so 1 mole of this is 3.99858. And what are the units here? It's grams per mole, right? Each of these is gram per mole, gram per mole, gram per mole. And so this is grams per mole. So I'm just going to write it out here. 399.858 grams for every 1 mole. So then I just multiply these two together. 1. Oh, come on, buddy. I get 489.0, we'll say 03. Okay, I always like to step back and say, does my answer make sense? So, 1.2 moles, that tells me I have more than 1 mole. If each mole weighs about 400 grams, and I have more than 1 mole, my answer should be more than 400. So that does make sense, right? So this next problem, we have a mass and we're going to molecules. Ooh, right? That's a little problem there. We're going from mass to molecules. So we're going to have to convert to moles first, then to molecules. So let's take this down here, get a little zoom in here. So we know that we're going to have to go from molecules to mole, then we're going to have to go to mass. Turn it into moles first. So molecules, start with what you're given. 1.50 times 10 to the 21 molecules. Okay, now how do I turn that into moles? You know that 6.022 times 10 to the 23rd molecules for every 1 mole. Nice. So now we're in terms of moles. Moles of, and by the way, the problem gives you C9H8O4. That's aspirin, which you may need after this video. So now we're in units of moles. Okay, so because molecules cancels out. So how do I turn moles into grams? Well, you use the term grams per mole. So I have to determine the molar mass of C9H8O4. So it's going to be 9 times 12.011 plus 8 times 1.008 plus 4 times 15.999. So I will tippy type that in my calculator if you guys want to play along at home. I got 180.159 grams per mole, right? So I know that since this is grams per mole, I can set this up as a ratio, grams of aspirin for every 1 mole of aspirin. Now it just so happens moles on the top, and my desired unit is mass, so I want mass on the top. So 180.159 grams for every 1 mole. Mole's going to cancel out. Perfect. So make sure that you get a calculator that you don't hate. So I'll be right back, actually, because I hate that calculator. So, okay, I'm back. All right. This calculator, I don't feel comfortable doing exponents on. I like to do one where it kind of really shows you the exponents. So it's 150, so I always put everything that's in the top in parentheses. So it's 1.5 times 10 to the 21. So in this calculator, I actually have a times 10 to the button, and you see how it's little up there, 21, and then you hit over, and it takes it down, and you hit in parentheses, right? Times 180.159. That's my whole top. That's the whole top. Then I'm going to hit divide by and put the bottom in parentheses. Always, always, always. Because if you don't, it's going to divide by 6.022 and then multiply by this. No, we need this in the bottom. We need the times 10 to the 23 in the bottom. So it's divide by 6.022 and then times 10 to the 23rd. Hit the arrow over, hit end parenthesis, enter. I get a mass of just put it down here in big words. Okay, so 0.449 grams. Woo! And that's of aspirin. Okay, so does this answer make sense? Let's go back and look. I can just tell by the exponents here that I'm not given a full mole, am I? They're giving me less than a mole. In fact, it looks like they're giving me about 1/10 of a mole. Am I correct? Because it's 21 and then times 10 to the 23. So if 1 mole weighs 180, it's going to be much less than 180. If they said, okay, if they were asking me how much does 1 mole weigh, I'd say 180. But if they're giving me this, I know for a fact they're only giving me a fraction, a very small fraction of a mole. So it's going to be a small fraction of this number. So that does make sense. So this number does make sense. So always double check that if it makes sense. So I hope that this helps. It seems like we actually did a little bit of review on how to name and how to calculate formula weight. So enjoy.